Welcome you all to the video lecture on signals and system. So today we are going to discuss about mathematical operation, that is addition of two discrete time signals. So let us consider the question as draw x1 of minus n minus 2 plus 2 x2 of n by 2 minus 1. Given as x1 of n, which is given by minus 1, 2, 3, 4, and x2 of n is given by 4, 5, minus 3 and then 2. So they have given x1 of n, they have given x2 of n. We need to find out first what is x1 of minus n minus 2 and what is 2x2 of n by 2 minus 1. Then we have to add both the signals. So as we know in mathematical operation, first operation is time reversal. So we have to do first reversal of a signal and then we need to do time shifting and then time scaling followed by amplitude scaling. So this is the priority which we have to follow while doing a mathematical operation. So the first operation is time reversal. So given is the first function which is given by x1 of minus n minus 2. Okay. So in this, while seeing the signal, what are all the operations involved? Here we have minus n. Minus n means that is your n is replaced by minus n, which is nothing but your time reversal operation. And then n is added or subtracted with some value, then it is said to be time shifting operation. So here n minus 2 we have, so time shifting operation is there. So first we have to apply time reversal operation followed by your time shifting operation. So first let me draw x1 of n first because they have given in a sequence manner. So first we have to draw x1 of n. What is x1 of n? Okay, so they have given x1 of n as minus 1, 2, 3, 4. Okay, and they have given particularly the arrow here. Wherever you have arrow, meaning that it is n equal to 0 value, and this is n equal to 1, this is n equal to minus 1, this is n equal to minus 2. Okay, so wherever we have arrow, meaning that that value is nothing but n equal to 0 value. So what are all the ranges we have for the given x1 of n? Minus 2, minus 1, 0 and then 1. Okay, and at 0 we have amplitude 3, at 1 the amplitude is 4, and then at minus 1 the amplitude is 2, at minus 2 the amplitude is minus 1. Okay, so either we can write here itself. So it is 3, it is 4, it is 2 and then it is minus 1. So minus 1, 2, 3, 4 we have. So this is n and the whole signal is nothing but x1 of n. If x1 of n is given, so we have to draw first what is x1 of minus n. Why? Because in the first signal we have time reversal operation followed by shifting operation. So what is time reversal? Whatever you have in the right side you have to draw on the left side. Whatever you have in the left side you have to draw on the right side. Okay, so we have 0 and 1. Whatever at the 0 position, the amplitude remains the same. So it will be of remaining 3 as it is. We have plus 1. Okay, that will become now minus 1. Whatever the amplitude here, you have to draw here. So it will become 4. And minus 1 will become now 1. The amplitude is nothing but 2. There is no change in your amplitude. Minus 2 will become plus 2. The amplitude at that position is minus 1. Okay. So this is nothing but your x1 of minus n. Okay. So we need to just reverse your signal. Whatever you have here, 0 position, the amplitude remains 3 as it is. 1 will become minus 1, minus 1 will become plus 1, minus 2 will become plus 2. So at 1 the amplitude is 4, that will come at minus 1, the amplitude becomes 4. At minus 1 the amplitude is 2, it will goes to n equal to 1 value. At minus 2 the amplitude is minus 1, so that we have to represent at n equal to 2. So first operation is over. Next we have to find out what is time shifting. Okay, So for time shifting, whatever we have within the braces, okay, that we have to equate to 0. Okay, so let me write here. So your second operation is time shifting. So we need to find out what is x1 of minus n minus 2. Okay, whatever you have functional value, we need to equate it to 0. So n value becomes, okay, minus 2. So what we have obtained previously, okay, this is our first diagram, this is our second diagram. So we have to apply this shifting operation to the second diagram. Okay, so wherever you have n, all the values of n we have to add with minus 2. So minus 1 become minus 1 plus minus 2 becomes minus 3, 0 minus 2 becomes minus 2, 1 minus 2 becomes minus 1, 2 minus 2 becomes 0. And whatever you have amplitude, as it is you have to draw, right? So 4, 3, 2 minus 1. So we have to first draw 4 and then 3. Just you are shifting the signal, that's all. 3 and then 2 and then minus 1. Okay. So in this manner we have to write. So this signal is nothing but x1 of minus n minus 2. Okay. So just shift this time duration. Okay. Minus n will become minus 3. 0 will become minus 2. 1 will become minus 1. 2 will become 0. And whatever the amplitude here at minus 1, it will go to minus 3. Okay. So just whatever you have from minus 1 to 2, it has been left shifted to minus 3 to 0. Okay. So first signal is 4 and then 3 and then 2 and then minus 1. So this is your first signal. Okay. And then we have to draw next what is 2x2 of n by 2 minus 1. Okay. And then only we can add both the signal. What is x1 of minus n minus 2? What is 2x2 of n by 2 minus 1? Both we can add. Okay. So first what is x2 of n? That we have to draw. Okay. So x2 of n is given by 4, 5, minus 3 and then 2. Okay. So we need to find out what is 2x2 of n by 2 minus 1. Okay. So what are all the operations first? It has been involved. Okay. When n is replaced by minus n, then it is reversal. Here there is no reversal operation. Okay. And then n is shifted by minus 1. So shifting operation is there. Okay. So first we need to draw what is x2 of n, and then we have to first apply shifting operation followed by time scaling followed by amplitude scaling. Okay. So here there is no arrow for the given signal, meaning that your first value is for n equal to 0 and second value is for n equal to 1 followed by n equal to 2 and n equal to 3. So now draw the diagram for x2 of n. So range is 0, 1, 2 and then 3. At 0 the amplitude is 4, at 1 the amplitude is 5, at 2 the amplitude is minus 3, okay, at 3 the amplitude is 2. So this is x2 of n. Your second step, we have to apply the time shifting operation. So first we need to find out what is x2 of n minus 1. Second step, what is n by 2 minus 1, x2 of n by 2 minus 1. Third step only we can draw 2x2 of n by 2 minus 1. In that way we have to proceed. So first step is a time shifting operation. So time shifting operation means what we have to do, the functional value we have to take and equate it to 0. So n becomes 1. So just shift your signal by 1, meaning that whatever the value you have for n, we have to add with 1. So 0 plus 1 will become 1, 1 plus 1 will become 2, 2 plus 1 will become 3, 3 plus 1 will become 4. And whatever the amplitude here, in the same way we have to draw. Okay. So 4, 5, minus 3 and then 2. Okay. So this is my x2 of n minus 1. And then x2 of n by 2 minus 1 we have to determine. So what we have to do? This is a time scaling operation. So for time scaling operation, we have to substitute that particular time scaling value, that is n by 2, which is equal to 1. Okay, so we have to equate whatever the value here. For example, if you have 3n, we have to equate 3n equal to 1. Example, if you have n by 2, then equate that to 1. If you have n by 4 equal to 1. Okay, so like that substitute and find out the n value. Okay, so n equal to 2. Here for your shifting operation, we have added whatever the value 1 with all the values of n. Here n equal to 2, this n equal to 2 you have to multiply with each and every instance of n. Okay, so it will become 1 will become 2, 2 will become 4, 3 will become 6, 4 will become 8. There is no change in your amplitude. Only you are changing your time. Hence it is called time scaling operation. Just equate n's coefficient. Okay, whatever the value n and with the coefficient, take that value, equate to 1, and whatever you have obtained here, multiply all those values of n to the previous diagram. So 1 will become 2, 2 will become 4, 3 will become 6, 4 will become 8. There is no change in your amplitude, it remains same. So 4, 5, minus 3 and then 2. Okay, so 4, 5, minus 3 and then 2 we have. This is nothing but x2 of n by 2 minus 1. Okay. So this is your second diagram. Okay. This is your third diagram. So for that I am going to apply the last operation. So what is the last operation? We need to find out what is 2x2 of n by 2 minus 1. So last operation is amplitude scaling. Just multiply all your amplitudes by 2. That's all. Okay. Just multiply all your amplitudes by 2. So what are all the n values? We have 2, 4, 6 and then 8. Just multiply all your amplitudes by 2. So at 2, what is the amplitude? 4. So multiply it by 2. So it will be h. And then at 4, the amplitude is 5. Multiply by 2, it becomes 10. At 6, the amplitude is minus 3. It becomes minus 6. At 8, the amplitude is 2. It becomes 4. Okay. So this is nothing but your 2x2 of n by 2 minus 1. So first operation is the shifting. Just shift the signal by 1. So from 0 to 3 it becomes 1 to 4. Second operation is time scaling. So just multiply each and every instant of n by 2 and your amplitude remains same. Third operation is amplitude scaling. So your time value, whatever the value you have for the previous signal, it will be there as it is. Only your amplitude you have to multiply by 2. So it becomes 8, 10 and then minus 6 and then 4. Okay. So now we have to add both the signals. X1 of that is your first signal with the second signal we have to add. Now just draw your x1 of n first. Okay. X1 of minus n minus 2. What is the signal? So for minus 3, 2, minus 1, 0 we have. The amplitudes are 4 and then 3 and then 2 and then minus 1. Okay. This is x1 of minus 1 minus 2. And what is x2 of 2? X2 of n by 2 minus 1. We have range 2, 4, 6, 8. The amplitudes are 8, 10, minus 6 and then 4. So we have to add both the signals. So when we want to add both the signal, first we have to write the ranges of the signal. So first signal range is -3, -2, -1, 0. Second signal range is, it is starting from 2, 2, 4, 6 and then 8. Okay. So there is no overlapping of the signal, so nothing to add in the particular instance. Okay. So for example, if you take -3, here there is no -3. So 4 plus 0 is 4. And for -2, 3 plus 0 is 3. And for -1, 2 plus 0 is 2. At 0, the value is -1. -1 plus 0 is -1. For 2, 8 plus 0 is 8. For 4, 10 plus 0 is 10. For 6, -6 plus 0 is -6. For 8, 4 plus 0 is 4. Okay. So this is the overall signal, which is nothing but x1 of n minus n minus 2 plus 2 into x2 of n by 2 minus 1. Okay. Thank you. Thanks for watching.